Okay, so before we move on and discuss more about sets and maybe then probability, it's worth just taking a few moments to discuss some examples of these operations on sets. And actually, maybe what I should have said here is really this operation of subtraction. We can also call it something else. This is called the complement of A, and you might think that's nonsense because I've told you this is the complement of A, but not just the complement of A, it's the complement of A, of course that's the universal set, the complement of A with respect to B. Okay, so we say we're taking the complement of A with respect to B. And in light of this more general definition, maybe it's worth meditating on what I mean by this, but we say this is the complement uh, of uh, of um, of A with respect to the universal set S. And of course, really what I'm doing is I'm removing from this whole thing the overlap between S and A, which kind of is in perfect agreement with this definition here of subtraction. Okay, so another way to write another way to write a bar is rather crudely as A minus S. Okay. Um, so let's talk ourselves through some examples. So we of course want one example for unions. So well, let's start off and kind of maybe just draw ourselves in a set or a pair of sets. So let's see, we have a set A and we have a nice big set B. So A and B. And in A, we are going to place, let's say, let's say 1 through 5. So we have 1, 2, 3, 4, 5. So set A contains 1, 2, 3, 4, 5. And let's just furnish this. Let me say with some braces and commas and all the other accoutrements. Now, here we're going to maybe be a bit more careful with how we place these in just a moment. But apart from that, we're going to say, let's say B contains 4, 5, 6, and 7. Now, clearly there's a problem here. The problem is that these kind of elements here are there's some sharing, there's some overlap, and I think you can see which ones there are. That's with the 4 and the 5. So the 4 and the 5 really should go in the middle. The 4 and the 5 really belong in the middle. But that kind of makes it really easy to see kind of what's going on. Of course, maybe I should furnish this by just writing that B is the set that contains, and we write down, we said it was, I think we were using yellow for B. We said it contains 4, 5, 6, and 7. Oh, that's not the color we were using, my mistake. We're using this kind of peachy color here. So it was 4, 5, 6, and 7. Very good. So now, what? Well, it's worth inspecting kind of where they overlap, and they seem to overlap again at 4 and 5, and at 4 and 5. So I think we're kind of really it's quite clear what's going on here because the Venn diagram spelt all of the answers out for us. So we're going to ask questions about the union. So we're going to say we're going to say A union B is all, remember we defined this as all the elements in A or B, and clearly that's just read off that Venn diagram there. So it's 1, 2, 3, 4, 5, 6, 7. Easy enough. How about the intersection? And remember that was kind of like an upside down U or an N. And the intersection is just all the elements that are shared, and we've circled them here, but that's just the 4 and the 5. So we have the 4 and the 5, and this is the intersection. So it's worth just writing here, this is the union, and this is the intersection. Okay, very good. Now, what if here what we actually have, what if overall what we really have is all the numbers, let's say from 0 up to 10. So really what we have here is 0, and we have 1, 2, 3, 4, 5, 6, 7, but we also have 8, 9, and 10. So we have 11 numbers from 0 to 10 inclusive. Maybe it's prettier if we have 10 numbers from 0 to 9. So we say we have these 10 numbers. So essentially what I'm really saying here then is that the set S, our universal set, just contains 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, excuse me, 8 and 9. And maybe I should color this more carefully because we said that the universal set, which kind of takes priority over everyone, we decided to color that with our lovely shade of blue. So, okay, very good. Now, now what? Well, we're in a nice place to now work out the complement of A. So the complement of A just contains all the elements that are not in A, right? So essentially what this really means is it's going to contain kind of these elements and this element here and this element here. So let's try to keep them roughly in order. So we have 0, then we have 6, we have 7, we have 8, and we have 9. And notice where these are coming from. Remember, S is the universal set, so it's everything that's on this board here. A is everything in the left circle, B is everything in the right circle. But essentially, all I'm after is everything that's not at all contained in the left circle. So I can't even include the 4 and the 5, even though it's included in B. I can't include them because they're included within A, so I'm not interested in them. And secondly, let's investigate B complement. So what's the complement of B? Worth investigating. The complement of B is all the elements, remember, all the elements not in B. So by the same token, we just don't include the 4 or the 5 or the 6 or the 7, but we do include the 0, we do include the 1, we do include the 2, we do include the 3, we do include the 8, and we do include the 9. Okay, so all we're not including is the 4, 5, 6, and 7. Very good. So now it's worth finally asking for the difference. So we'd say A minus B, and this is the complement of A with respect to B. So if we have a look, we're just saying all of the elements in this circle, but we remove everything in the overlap between A and B. So we just remove the 4 and the 5, and I think you can see we just have the 1, the 2, and the 3 left over. Worth investigating the other way around, so B minus A, what's that going to be? Well, again, B is everything in this circle here, and we're wanting to remove everything in A, so we're removing what's in their overlap, and we're just left with the 6 and the 7. So B minus A is just that 6 and that 7, okay? Very good, so I think that's probably just quite nicely represented what I mean by unions, intersections, complements, and differences. So maybe I'll just furnish this by saying complement of A. This is, of course, the complement of B. And maybe, just to save myself some sanity and some writing, I'm just going to copy these, and I'm just going to say the complement of A, we'll say with respect to B, and this is the complement of B with respect to A, because we think of removing what's in A from B on the second one, and we would think of removing what's from A, what's in B in the first one.